Hello guys, welcome back. In this video, we're going to implement a new strategy called Random Agent. The topics are as follows. 1. Disclose the drawbacks of the omniscient agent. 2. Discuss the idea behind the random strategy. And 3. Implement the random agent in Python. Let's start talking about the drawbacks of the omniscient agent. You guys probably already realized it, which is the biggest drawback of the omniscient agent. It's impossible to deploy the omniscient agent in the real world scenario, because the assumption made for this agent, which is the omniscient agent knows the value of the probability of success from each bandit machine in advance, is impossible to fulfill. This is by far the biggest drawback of this type of agent. The results of the omniscient agent can be really useful. We cannot use it as a solution, but we can use it to set a measure of top score performance to fairly compare the performance among the agents. Let me clarify it. For example, here we have the performance of 5 different agents plus the omniscient agent. You guys can see that the omniscient agent is the agent with the highest performance score in comparison with all the others. But why does it happen? The reason is really simple. The omniscient agent knows the probability of success from each bandit machine and chooses the most profitable one in every single trial. Consequently, it reaches the maximum possible score after a lot of trials. We can say that it reached the top score. However, we know that a real agent doesn't know the value of the probability of success from each bandit machine in advance. For this reason, each agent has developed a unique strategy to infer this value through the trials. The agent with the best strategy will get almost as much score as the omniscient agent, here represented by the agent 4. I hope that makes sense for you. The first agent to study is the random agent. Let's discuss the idea behind this strategy. In the real world, the agent doesn't have any clue about the value of the probability of reward from bandit machines. In order to find out the most profitable one, let's begin with the simplest approach that I can think of. What would be the simplest one though? It will come from the naive gambler. Naive gamblers usually don't have any strategy set to follow. They just choose bandit machines randomly and pull the levers. After a long time span, the naive gamblers begin to realize where the value of the probability of success from each bandit machine is converging to. This might not sound the best strategy, but we have a start point. In this section, we're going to implement the naive gambler and observe its performance. I hope that you guys got the idea so far.